Hey guys, welcome to Algebra 1, Lesson 25. We have two concepts we're going to talk about today. First, we're talking about using the distributive property for equations that are a little bit bigger with more variables and exponents. Then we're going to be talking about simplifying equations with decimals. So let's get started first with our equations using the distributive property. So remember, the distributive property looks something like this. If I have 4p times x plus 3y, to use the distributive property to simplify, that means that I have to multiply 4p first by x, and then by a positive 3y. And that distributes my 4p to each part of the parentheses. So 4p times x becomes 4px, plus, because this is a positive 3y, 4p times 3y, 4 times 3 is 12, p and y. So I end up with 4px plus 12py. And remember that the order of these variables doesn't matter. If I wrote 4xp plus 12yp, same exact thing. I can't combine these any further because they're not like terms, so that's where you stay unless you know what p stands for, x stands for, and y stands for. So now we're going to look at some that are slightly more, not complicated exactly, but yeah, a little more challenging. So let's look at this one. xy times y squared minus x squared times z. Okay, we're going to do the same thing. We're going to use this distributive property to simplify. So that means first, I'm going to multiply xy times y squared. Then, I'm going to put my plus sign because this minus sign is going to come with the term to make it negative. So plus xy times negative x squared z. Okay? Now I multiply it out. X times y squared. Remember, you can combine your variables when they have those exponents. Y times y squared, that's the same as having y times y times y, which is y3. So our rule is that you just, when you're multiplying the same variable, you add your exponents, right? So 1, because when you have no exponent, your exponent is 1. 1 plus 2 is 3. So this becomes x, y, 3, okay? You don't need to go through all of these steps each time you do it. This is just to show you as I'm teaching you. You can do it really, really simply. Okay, so x, y, 3 plus x times negative x squared. That's going to be negative x cubed. Y times, well, there's no other y, so we just have one y and one z. So that's your problem. You could also write it like this. X, y cubed minus x cubed y z. Okay? Both of those are the same thing. Let's try another one. Let's look up here. I have 4xy cubed times x to the 4th y minus 5x. So I'm going to show you how to do this more in your head. Okay, let's look at our first part, which is our coefficient, the 4. Are there any whole numbers here to multiply the 4 by? No, it's an understood 1. So this is just going to be 4. X times x to the 4th, so that would be like having x1. So 1 plus 4 is 5. So that becomes x5. Y3 times y. Remember, that's like having a 1 right there. So 3 plus 1 is 4. So this becomes y4. So you have 4x5, y4. How you doing? Did you hang in there with me? Do you understand? Let's keep going. Minus 5x. So that's a negative 5 times a positive 4 gives you a negative 20. X times x is x squared. There's no y's over here, so we just keep this y3. So it's 4x to the 5th power, y to the 4th power, minus 20x squared 3. y3, excuse me. All right, let's try another one. ay minus 4y to the 5th power times 2x squared y. So our our single term doesn't have to be in front of the parentheses. It can come behind the parentheses and we still use the distributive property. So I have 2 times, is there any coefficient over here? Nope, so that means it just stays 2. X squared, any x's over here? Nope, so it just stays x squared. Y, any y's over here? Yep, right here. So y plus y squared. No other a's, so it stays the same as just a. So I have 2x squared, y squared, a, minus 4 times 2 is 8. No other x's, so we'll just keep our x squared. Y5 times y1 is y6. So I have 2x squared, y squared, a, minus 8x squared, y6. Okay, let's do another one. 8m squared x times 5m cubed x minus 3x5 plus 2x. Okay, let's multiply each term, starting with the first one. 8 times 5 is 40. M squared times m cubed, add your exponents. 2 plus 3 is 5. X times x is x squared. Now we go on to our next term. 8 times negative 3, negative 24. M squared times, no m's, so that stays the same. X times x to the 5th power, 1 plus 5 is 6, so it's x6. No more variables with either term, so I move on. Positive 2 times 8, positive 16. M squared over here, no m's over here, so it stays the same, m squared. X times x is x squared. Okay, let's double check to make sure that none of our terms are like terms. Nope, none of their variables match exactly, so this is as simplified as our expression gets. Okay, so that's how you solve these types of problems. We say that you are expanding the problem. So in your practice set, you'll see that it tells you to expand. Okay, now let's look at decimals. Okay, let's look at the decimals. So first of all, if you are adding or solving an equation like this, 0.4 plus 0.2 equals 4.6, you can solve that just as it is. But sometimes the decimals get complicated, and so it's easier if we could get rid of the decimals. So there is a way to get rid of the decimals in your equation. This way is to multiply every term in your expression, every term in your equation, by the power of 10 that will get rid of the decimal in every single term. It has to be the same power of 10 for every term. So you have to look at each term and see what power of 10 would be needed and pick the biggest power of 10 that you need. For this one, I just need, if I multiply this by 10, it'll move it over, I get rid of the decimal point. If I multiply 0.2 by 10, it'll move it over, I get rid of the decimal point. If I multiply 4.6 by 10, it will move it over and I get rid of my decimal point. So all of these terms, the highest power of 10 is just 10, so that's all I need to do. So I'm going to multiply 0.4 by 10, and that gives me 4. Plus 0.2 times 10 gives me 2m equals 4.6 times 10 is 46. So now I have an equation with no decimals. It's a lot more inviting, right? So let's try solving it. First I'm going to subtract 4 to get rid of it from both sides, leaving me with 2m equals 46 minus 4 is 42. Divide both sides by 2. Running out of room. Okay, I'm going to write it over here. n equals 21. And then I would solve it by putting 21 back in place of m. I'm not going to do it right now for time, but in your homework, you do need to go ahead and check that your answer is correct. Also, you can put 21 back into place of m in the very, very first equation, and it's going to give you 4.6. Okay? Let's try another one. Here I have 0.002k plus 0.02 equals 4.02. Well, what power of 10 would I need to make this into just 2? Well, I need to move my decimal point 1, 2, 3 places. So that means I need the power of 10 with 1, 2, 3 zeros. So I need 1,000. Here, I only need 2 zeros. 1, 2. so I need 100. Here I only need 2 zeros, 1 0, so I need 100. What is the largest power of 10? 1,000. So that means I need to multiply all of my terms by 1,000. Even though these only need 100, I have to multiply every term by the same power of 10. So I'm going to multiply each one of my terms by 1,000 to get rid of my decimal. So here I go. 0.002 times 1,000 just gives me 2k plus 0.02 times 1,000. Well, that moves my decimal point 3 places. So this becomes, we annex a 0, that becomes 20. 4.02, well, we move it 1, 2, 3 places, so we have to annex 0. This becomes 4,020. Okay? So now all of your like terms, they have not changed in their value. I'm going to go ahead and solve by first subtracting 20. Subtract 20 from both sides, leaving me with 2k equals 4,000. Divide by 2. Oops. Divide by 2. K equals 2,000. Okay? To check this, remember you put 2,000 back in place of k. So if I wanted to put 2,000 back in place of the k right up here in my original equation, let's take a look at what that would look like. It would be 0.002 times 2,000 plus 0.02 equals 4.02. Okay, let's check it out. 0.002 times 2,000. Let me write it down here so you can see that a little better. Well, I multiply 2 times 0 is 0, 2 times 0 is 0, 2 times 0 is 0, 2 times 2 is 4. I don't need to multiply the rest of my zeros. I just need to move my decimal point 3 places over, 1, 2, 3, and so I get 4. So 0.02 times 2,000 is 4. So now I have 4 plus 0.02 equals 4.02. Well, 4 plus 0.02, if I write it over here so you can see it even better. 4 could be written as 4.00 added to 02, 4.02. So I have 4.02 equals 4.02. So that proves that this is an accurate way to solve equations with decimals. Okay, go ahead and pause now to do your practice. Okay, you should be done with your practice. Letter A is x, y, 4, p minus x, y squared, p. X, y, 4, p minus x, y squared, p. B, 2x squared, y squared minus 2x squared, y. C, 3x p8 minus 3x3 p11. D, 2x squared m4 minus 8x squared m3. If you need to rewind and listen to those again to make sure you got those right, go ahead and do that. Letter E, m equals 34 over 13. That may have seemed like a weird number. It may have made you second guess yourself, but that's what it was, 34 over 13. F, x equals 210. Okay, that's all for now. I hope you guys have a great day. Love you so much. Bye.